All right, following up on the last one, I did just want to go over two more similarities and then we'll get to an example. So, first of all, one other similarity between multiple dispatch and function overloading is if they're defined on like an inheritance tree or a subtyping tree, if there isn't an implementation for the specific type of arguments that are supplied to the overloaded function, then it'll just go up the tree to find the most specific implementation. So in both overloading and multiple dispatch, that happens. And then one other thing is there can be possible ambiguity in the call. And again, that happens in both overloading and multiple dispatch. And I had originally been exposed to that through multiple dispatch in Julia, but and then I was like thinking about it and I was like, it seems like it could happen in both. And sure enough, it does happen. So I made an example in C#, for example, and it gave me the same ambiguity error that Julia would give in multiple dispatch. And we can kind of go over the situation of that ambiguity if we want later. But I want to go through one example of when the static time type and the compile and the runtime type would be different. Okay, and so we can just use that civic and car example again. Okay, so here's our example. We make a car class and then we make a civic class. So in the civic class, a Honda Civic is a subtype of a car, right? So the civic class would inherit from the car class, okay? And then we make some function that's going to be like overloaded, right? And we can call it load just to make it easier to remember. And then if we implement the load function on the civic, we can say like the civic is loading. And then if we implement the load function on the car, we can just say like the car is loading, and we can just have those print to the console. That can be the whole implementation. Again, so we have a car as the supertype, we have a civic as the subtype, and then we have this overloaded function called load, and on the civic it says civic loads, and on the car it says car loads. Okay? And then let's also pretend we're in a language with multiple dispatch as well, and we're going to do the same thing, except instead of the loads function, we'll call it the dispatch function. Okay, so we'll define some dispatch function on a car, and it'll say the car is dispatched, and we'll define a dispatch function on the civic that says the civic is dispatched. Okay, and so just so if you're not watching, so you have it clear in your head if you're just listening, you can kind of think of it as like a little table with 2 rows and 2 columns. If the tables are the types, then you've got the car and the civic as the 2 rows, and then the columns would be like there'd be load and dispatch, right? So we've got 4 implementations here. Okay. And so in the overloaded function, if we're and we're going to just do those examples to see the behavior operating differently, okay? So if we're in a statically typed language and we want to make a list, we want to make a car and we want to make a civic, and we want to make a list that has one of each, right? Then in a statically typed language, we would have to make a list of cars, right? And then once we make a list of cars, we can add a civic to it and we can add a car to it, right? And so then if we loop through that list and we call the load on each element in the list, what do you think is going to happen in the overloaded static situation, right? Both of them are going to call car loads because it's running based on the static type, right? So the static type of the list is a list of cars, and the elements we supplied to it, one is a car and one is a civic, but that doesn't matter. What matters is the compile time static type. So again, when we loop through that list and we call the load function on both the car and the civic, even though they're actually a car and a civic, they're compiled as cars. So both of those cases calls the car as loading. And then, of course, in a dynamic language with multiple dispatch, but this is obviously not a multiple dispatch case. This is just a single dispatch case. If we loop through a list of one car and one Civic, it will call the Civic dispatch and it will call the car dispatch. So the multiple dispatch or the dynamic dispatch might do, I don't want to say that one is like, quote unquote better than the other or what you would expect, but someone might, a newcomer might expect the Civic implementation to be called on the Civic and the car implementation to be called on the car. So I think the dynamic case might be maybe a little more intuitive, or it's at least a little bit more flexible maybe. So in any case, not to bang on one way or another, that's just the difference, right? So so when Julia, for example, is dynamically typed and and has multiple dispatch. So if you do that loop in Julia, it will have the Civic dispatching and the car dispatching. And if you do it with overloading in C#, for example, it will say the car is loading on both of them. Okay, so cool, thanks.